Good morning everybody. Welcome back to our channel Sri Education. In previous class we learned the distance, midpoint, section formula and centroid, area of a triangle in Heron's formula. These are all in coordinate geometry, 7th chapter coordinate geometry. So today class is 10th class mathematics, 8th chapter similar triangles. 8th chapter similar triangles. First we learn the similarity. Here similarity means same shape are called similarity. Shape and here size so are congruency. So here similarity. So here same shape are called similarity. So here suppose these are the similar squares. So here similar triangle, similar circle. Same shape are called similarity. Same shape and size are called congruency. So that is the difference of similarity and congruency. Now exercise 8.1. So first question, in triangle PQR, ST is a line such that PS by SQ is equal to PT by TR and angle TSP equal to PRQ. These two angles are equal. Prove that PQR is a isosceles triangle. Isosceles triangle means any two sides are equal, that is the isosceles triangle. So now this triangle is isosceles triangle. We prove that. So here we draw the diagram PQR triangle. So PQR triangle, here ST PS by SQ equal to PT by TR and angle TSP equal to angle QPRQ. These two angles are equal. So we show that these two are equal. These two angles are equal means opposite sides are equal. Opposite sides means here PQ equal to PR. PQ equal to PR. So two sides are equal means PQR is an isosceles triangle. So we can write that one. So first we write the given data. Here given triangle PQR. So here ST is a line such that ST is a line. So here PS by SQ. So here PS by SQ equal to PT by TR. Next, two angles are equal. TSP equal to angle PRQ. These two angles are equal. So now here we require to prove that here triangle PQR is an isosceles triangle. Prove that PQR is an isosceles triangle. So here triangle PQR is an isosceles triangle. Isosceles triangle. So here first we write the proof. Here proof equal to in triangle PQR equal to, already we know that PS by SQ equal to PT by TR. We know that given in question. So here this is the basic proportionality theorem. So basic proportionality theorem means these two are equal means here converse proportionality theorem ST is parallel to QR. So here PS by SQ equal to PT by TR. So converse, we use the converse basic proportionality theorem. ST is parallel to QR. So therefore here ST is parallel to QR. We use the converse basic proportionality theorem. Converse of basic proportionality theorem. So here these two are parallel means here ST is parallel to QR. ST is parallel to QR. So here SR is intersecting, here SQ is intersecting line means here these two angles are equal. Here we take TR, intersecting line means here this angle and this one. These two are equal. So here first we write here ST is parallel to QR. So that equal to here angle PST. Angle PST equal to PQR. These two are corresponding angles. So equal to angle PQR. So therefore corresponding angles of lines ST is parallel to QR. ST is parallel to QR. So that's why here these two angles are corresponding angles are equal. This is the equation 1. Next, we take here ST is parallel to QR and TR is a transversal. So here angle PTS equal to angle PRQ. These two are equal. So this is the equation 2. So here also corresponding angles. So these two angles are equal from 1 and 2. From 1 and 2 equations implies here. So PTS. So these two are equal. So here angle PQR equal to angle PQR equal to angle PRQ. PQR equal to PRQ. These two angles are equal. These two angles are equal means here angle Q equal to angle R. We write angle Q equal to angle R. Q opposite side. Here angle Q opposite side is PR. Equal sides, opposite angles, sides are equal in a triangle. So here PQ equal to PR. So therefore PQ equal to PR. Angles opposite sides are equal. So equal angles opposite sides are equal. Opposite sides are equal. So here two sides are equal means so PQR is an isosceles triangle. So this is the first one solution. Next, second one, in the given figure, LM is parallel to CB. LM is parallel to CB and LN is parallel to CD. Proof that AM by AB equal to AN by AD. AM by AB equal to AN by BD. So here we use the basic proportionality theorem. Prove this one. Here first these two are the parallel lines. Here we prove that AM by AB equal to AN by AD. So here in the given figure LM is parallel to CB. So first we write the given data. Given LM is parallel to CB and LN is parallel to CD. These two are parallel and these two lines are parallel. So here required to prove that here AM by AB equal to AN by AD. So we write that one. So here AM by AB equal to AN by AD. So here we prove these are equal. So now here we write the proof. So in first we take the triangle ABC. So here triangle ABC. So ABC. This triangle we draw the subdiagram here. First we draw the triangle ABC. So here LM. This is the triangle ABC. These two are parallel. One side is parallel to another side's midpoint line joining line. Midpoints joining line. So these two are parallel means here we use the basic proportionality theorem. Here AM by MB equal to AL by LC. We use the basic proportionality theorem here. So here first we use the basic proportionality theorem here. LM is parallel to in triangle and LM is parallel to CB. So this is the given in question. So here we use the basic proportionality theorem. AL by LC equal to AM by MB. AL by LC equal to AM by LC. So this is the basic proportionality theorem by basic proportionality theorem. So now next we take the down triangle. So here we take this one, here triangle ACD, NL. These two are parallel. Once it is parallel means here also apply the basic proportionality theorem. AN by, next here we take that ACD triangle. Here ACD triangle. So NL and DC are the parallel. So that is given question. So here triangle ACD, LN is parallel to CD. So we use the basic proportionality theorem. L by LC equal to AN by ND. So here we write the basic proportionality theorem. AL by LC equal to AN by ND. So from 1 and 2 equations, here two left hand sides are equal. So right hand sides are so equal. AM by MB equal to AN by ND. From 1 and 2 implies here AM by MB equal to AN by ND. So this one, first we write the reciprocal. So here we write reciprocals. Here these reciprocals means we write the numerator, denominator in numerator. That equal to MB by AM equal to ND by AN. So here MB by AM equal to ND by AN. So here this one we add the both sides 1. So here both sides 1 means here MB by AM plus 1 equal to ND by AN plus 1. So here we do the LCM. Here LCM is AM equal to MB plus AM equal to ND plus AN. Here also we do the LCM. ND plus AN by AN. So here so here MB plus AM is their numerator. So we observe the diagram MB means year to year plus AM year to year, total A to B. Right side also same. ND plus AN. These two, sum of these two lines equal to AD. We write that one. So here AB by AM equal to AD by AN. So here this one. So here asking AM by AB equal to AN by AD. So here we write this is also, here we write reciprocals. We write the reciprocals. We write reciprocals. Here reciprocals means here AM by AB equal to AN by AD. So this is our required solution. So this is complete solution of second one. Next, third question. In the given figure, DE is parallel to AC and DF is parallel to AE. DE is parallel to AC. So DE is parallel to AE. And next, DF is parallel to AE. DF is parallel to AE. Proof that BF by EF is equal to BE by EC. BF by FE equal to BE by EC. So BF by EF equal to BE by EC. These two ratios are equal. So first we use the basic proportionality theorem and prove it. So here first we write the given data. So here given DE and AC are the parallel lines and DF and is parallel to AE. So here given that DE is parallel to AC and DF is parallel to AE. So these two are parallel lines and DE is parallel to AC. DE is parallel to AC. These two lines are parallel. So next we prove this one. Here BF by FE equal to BE by EC. So now first we take the here required to prove that BF by FE is equal to BE by EC. So we prove required this one. So now we write the proof. Here we write the complete explanation of proof. So first we take the triangle ABC. So here ABC. So we take this complete triangle. So here AC parallel to DE. So compare these two parallel lines. We use the basic proportionality theorem. So here in triangle ABC, here in triangle ABC, DE is parallel to AC. DE is parallel to AC. So here DE is parallel to AC in triangle ABC. So here we use the basic proportionality theorem. AD by DA equal to DE by EC. So here we draw the subdiagram here. So if you are confused, we draw the subdiagram here. ABC. ABC, complete triangle. So here we draw the line DE. 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 So these two are parallel in question given. So here these two are parallel means here we use the basic proportionality theorem. So here BD by DA equal to here BE by EC. BE by EC. Here because basic proportionality theorem. So here this one equation 1. So next here we take in the triangle, here another two parallel set lines are there. So this pair is there. So now compare this one. Here in triangle ABE. In triangle ABE, here DE is parallel, DF is parallel to AE. So we take DF is parallel to AE. So ABE in triangle ABE. So here we draw the subdiagram. So here we take this one like this. Here. So here ABE. So here these two FD. These two are parallel. So here one pair of parallel lines is there in triangle. So here we use the basic proportionality theorem. Here we use the basic proportionality theorem. BD by DA equal to DF by FE. FE. So here we write that one. Here BD by DA equal to BF by FE. So we use the basic proportionality theorem. So here also, so these two are equal. Now first we observe the 1 and 2 equations. Here BF by EC equal to BF by EC. So here FE. So FE. Here BD by DA. BD by DA. So left hand sides are equal. So left hand sides are equal means here from equation 1 and 2 implies, here 1 and 2 implies. Here equation 1 and 2 implies we write here right hand sides are equal. Equal means here BE by EC equal to BF by FE. So now here we compare this one. Here just BF by FE. So here BF by FE, BF by FE, BE by EC. So we write first this one. Here BF by FE equal to here BE by EC. So this is the required proof. This is the complete third one proof. Next, fourth one, proof that a line drawn through the midpoint of line, one side of the triangle is parallel to another side bisect the third side. So here, use the basic proportionality theorem. Proof that a line drawn through the midpoints of one side of the triangle is parallel to the another side bisects. So here, two sides are bisects. The third side, parallel to third side. So here, midpoint of a one line side of a triangle is parallel to the another side. Now here already we draw the one triangle ABC. So here this triangle, so here one side through the midpoint of one side of a triangle. So here first here DE with here DE. So these two are the AB midpoint is D, means these two distance are equal. Here suppose X centimeters, here also X centimeters. These two distance are equal. So here we can prove that AC midpoint is E. We can prove that AC midpoint is E. So we use the basic proportionality theorem and prove it. So here first we write the given. Here given in a triangle ABC. In a triangle ABC. Here D is a midpoint of AB. In triangle ABC, D is a midpoint of AB. So already we draw the triangle. So here D is a midpoint of AB means here BD equal to DA equal to we say X. So here AD equal to DB equal to X. So here these two are parallel. So DE is parallel to BC, parallel to the another side of bisects. So these two are parallel to the another side of bisects. So here parallel are DE is parallel to BC. DE is parallel to BC. Now we are required to prove that here AC, E is a bisect of AC. So here E is bisects AC. So we proved this one. Now we write the proof. So here we take the triangle in ABC. So here ABC, BC is parallel to DE. So BC is parallel to DE. Already we know that. BC, here DE, we write anyone, same. DE is parallel to BC. DE is parallel to BC. We use the basic proportionality theorem. AD by DB, AD by DB equal to AE by EC. AE by EC. So here we use the basic proportionality theorem. Here already it is given basic proportionality theorem. So here now this one AD by DB. Here AD by DB equal to X. So both are equal to X. X means here X by X equal to AE by EC. AE by EC. X get cancelled. Here 1 equal to AE by EC. AE by EC. AE by EC equal to EC we carry to the left hand side. Here EC equal to AE. EC equal to AE. So these two are equal. So these two are equal means E is the midpoint of AC. EC equal to AE. EC equal to these two are equal means E is the midpoint of AC. So therefore E is a midpoint of AC. So here E is a midpoint of AC means here E bisects AC. So here our proof is, here required proof is E is a bisect of AC. So E is a bisect of AC. So this is the complete fourth one solution. Next, fifth one, prove that a line segment joining the midpoints of any two sides of a triangle is parallel to the third side. So here we draw the triangle, two sides midpoint is parallel to the third side. So using the converse of basic proportionality theorem. Now here prove that a line segment joining the midpoints of any two sides. So here already we draw the triangle, midpoint, line segment joining the midpoints of any two sides. Midpoints. So these two are equal, these two are equal. These two midpoint is here, this one. So here ABC triangle, AB midpoint is D. So here AC midpoint is E. So of a triangle is parallel to the third side. So here we can prove that DE is parallel to BC. DE is parallel to BC. So here DE is parallel to BC. First we write the given data. Here given in triangle ABC. In triangle ABC, here D is a midpoint of ABC. So here D is a midpoint of side AB. So here AB means midpoint means AD equal to DB. AD equal to DB. These two are equal. Next, here E is a midpoint of AB. AC. AC. E is a midpoint of AC. That equal to AE equal to EC. AE equal to EC. EC. Now here we can prove that these two DE and BC are parallel. So parallel to the third side. So here we are required to prove that here DE is parallel to BC. We can prove this one. Here we write the proof. Here in triangle ABC. In triangle ABC. So here D comma E are the AD and AC midpoints joining line. Midpoints joining line. Here we write midpoints lining join means AD by DB equal to here AE by EC. So here AD by BD equal to AE by EC. Here we use the converse of basic proportionality theorem. Here BE is parallel to DC. Direct we write. Otherwise here AD equal to DB. So here AD by DB equal to we write AD. AD. Next AE. AE by EC. EC equal to we write AE. AE. these two are get cancelled, these two are get cancelled. Here 1 equal to 1. 1 equal to 1 means these two are equal. So here ratios are equal. Ratios are equal means here ratios are equal. Equal ratios means here these two are parallel. So otherwise direct we use the basic proportionality theorem. Here AD by BD, DB equal to AE by EC. So here automatically here therefore DE is parallel to BC by use the basic proportionality, converse basic proportionality theorem. Converse of basic proportionality theorem. Basic proportionality theorem. So here this is the our required proof is BE is parallel to DC. So here finally DE is parallel to BC. So this is the fifth one complete solution. Next here sixth question. Here in the given figure DE is parallel to OQ and DF is parallel to OR. DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. EF is parallel to QR. So first observe this diagram. This is the triangular prism. So here base is the QOR is the one triangle. Here we cut the midpoint. Here DEF is the another triangle. So here we prove that EF is parallel to QR. So here we use the basic proportionality theorem. So here given the figure DE is parallel to OQ. DE is parallel to OQ. First we write the given data here. Given here in triangle PQR. In triangle PQR here DE is parallel to OQ. DE is parallel to OQ and DF is parallel to OR. So here we can prove that EF is parallel to QR. Required to prove that here EF is parallel to QR. So now we write the proof. Here proof equal to here in triangle. So first here we observe this one. Here PQO is one triangle and POR is another triangle. So here first we use the POQ triangle. POQ. So this triangle we use here POQ. POQ. So here ED. So here these two are parallel. These two are parallel means in triangle these two lines are parallel means we use the basic proportionality theorem. PE by EQ equal to PD by DO. So we write that one. So here this diagram we use the basic proportionality theorem. So here in triangle POQ equal to here PE by EQ equal to here PD by DO. So this is the equation 1. So since here already we know that here in triangle POQ already we know that DE is parallel to OQ. So here we use the basic proportionality theorem. Basic proportionality theorem. So here we write this one. Next here we take the another triangle POR. We use the POR. Here DF is these two are parallel. These two are parallel. POR. So we take this one. Here these two are parallel. So here also we use the basic proportionality theorem. So here first in triangle POR. In triangle POR already we know that DF is parallel to OR. DF is parallel to OR. So DF is parallel to OR means here we use the converse basic proportionality theorem. So here we write here D PF by F are equal to PD by DO. So here by basic proportionality theorem. So here this is the equation 2. So we observe this one from 1 and 2 here PE by EQ. So here PD by DO. Here PD by DO. So right hand sides are equal. Right hand sides are both are equal means these two are equal. So here from equation 1 and 2 implies here PE by EQ equal to PF by FR, PF by FR. So these two are equal. These two are equal means thus the line EF divides the two sides of PQ, two sides of PQ. Here two sides are equal means automatical third side also parallel. EF is parallel to PQ. So here this is the triangular prism. Here two sides are parallel means a third side also parallel. So we write EF is parallel to QR. So we write that one. Thus the line EF is divides the two sides PQ and PR of triangle PQR in the same side, same ratio. So same ratio, hence here EF is parallel to OR. So here we use the converse basic proportionality theorem. Converse basic proportionality theorem. So this is the complete sixth one solution. This is the first half and next second half. Next seventh one, in the adjacent figure A, B, C are points on OP, OQ and OR. So OP, OQ, OR such that AB is parallel to PQ. AB is parallel to PQ. These two are parallel. So and AC is parallel to PR. AC is parallel to PR. Now we show that BC is parallel to QR. BC is parallel to these two lines are parallel. So here first we take the POQ triangle. Here we use the basic proportionality theorem. Here also next we take POR triangle. Here also we use the basic proportionality theorem. So that is two are equal. So here in the adjacent figure A, B, C are the midpoints of OP, OQ, OR. So here midpoints means these two sides are equal. OA is equal to OP and OD equal to DQ. So here midpoints. Now next respectively such that AB is parallel to PQ, AC is parallel to QR. These two lines are parallel. These two lines are parallel. Then show that a third set pair. These two are parallel. We show these two. BC is parallel to QC. So now here first we write the given in triangle. Here we write the given data in triangle PQR. Here PQR. So here in triangle PQR. So here PQR, here AB is parallel to PQ. AB is parallel to PQ and AC is parallel to PR. So here now we require to prove that here BC is parallel to QR. Now next we write the proof. In this complete triangle PQR, first we take the subdiagram here PQO. So here we use the we take this one here POQ triangle POQ here BA. So these two are parallel. Here we use the basic proportionality theorem. Here OA by OP, here OB by OQ, because here already we know that AB is parallel to PQ. Already AB is parallel to PQ. So we write that one. So here first we use the basic proportionality theorem. In triangle POQ, here already we know that AB is parallel to PQ. AB is parallel to PQ means here we use the hence basic proportionality theorem. OA by OP equal to OB by OQ. So by basic proportionality theorem. So here next here we take the another diagram. Next this is the equation 1. So here we take equation 1. Now next we take the POC triangle. So here next P POC triangle AC. So here these two triangles. So here now we take these two triangles. These two are parallel. These two are parallel. Here we apply the basic proportionality theorem. OA by OB equal to OC by OC by PQ. Here R. P OC by OR. So here we use the basic proportionality theorem. Here in triangle POR. In triangle POR, already we know that AC is parallel to PR. AC is parallel to PR. AC is parallel to PR. So now here, hence here OA by OP equal to here OC by OR. So this is the equation 2. So here also we use the by basic proportionality theorem. So here from 1 and 2, from equation 1 and 2, we observe these two equations, left hand sides are equal. So these two are equal. So here we write that one. Here OB by OQ equal to OC by OR. So here thus the line BC divides the two sides here OQ and OR. So here OQ and OR of triangle OQR. So finally we observe this triangle OQR. So these two OB by BQ, OC by QR. So here we use the converse proportionality theorem. So here in the same ratio, here therefore BC is parallel to QR. So by use the converse of basic proportionality theorem. So here hence proof. This is the complete solution of 7th one. Next, 8th question. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at a point O. Show that AO by BO is equal to COBO. So here ABCD is a trapezium. AB is parallel to DC. One set of sides are parallel. So its diagonals intersected at the point O. Show that AO by BO equal to CO by BO. Now here already we draw the parallelogram ABCD. So here ABCD is a parallelogram. This parallelogram here AB and DC are the parallel lines. AB and DC are the parallel. So here these two lines parallel, we draw the another line. So here diagonals AC and BD are the diagonals intersect each of the point O. So here intersecting point is O, diagonals intersecting point. Now we draw the line parallel to the AB. Here EF is the parallel line of AB and DC. So we draw the diagram. First, here we write the given data. ABCD is a trapezium. So here given that ABCD is a trapezium and AB is parallel to DC. So now here we require to, here intersecting point of the diagonals is O. So here required to prove that here AO by BO equal to CO by DO. So we prove this one. Now we write the proof. Here proof equal to in triangle. So here in trapezium ABCD. Here ABCD is a trapezium. In trapezium ABCD. So ABCD is a trapezium. Now we draw the line EF is parallel to AC and DC. So here we write the construction steps. Draw a line EF which is parallel to DC and AB. So here these three lines are parallel. So therefore AB is parallel to EF is parallel to ADC. So here DC. These three lines are parallel. Now in triangle we take the triangle. In triangle A DAB. So in triangle DAB. So here EO and AB are the parallel. EO and AB are the parallel lines. So here we draw the subdiagram. Here we take this one DEOAB. So here we use the basic proportionality theorem. So here we use the basic proportionality theorem. Here EO and AB are parallel. Means here DE by EA equal to DO by OB. That is the basic proportionality theorem. So here we apply the basic proportionality theorem. Here DE by EA equal to DO by OB. So this is the equation 1. So next we take the another triangle. In triangle ADC. We take this one. So here this triangle, here these two are DC and EO are parallel. So here DC is parallel to EO. These two are parallel. These two are parallel means here we draw the subdiagram. Here this is the subdiagram. So now here EODCA. So here we apply the basic proportionality theorem. Here we apply the basic proportionality theorem. Here DE by EA equal to CO by OA. So this is the equation 2. So observe these two equations here. DE by EA. So left hand sides are equal. Therefore from equation 1 and 2 implies here DO by OB equal to CO by OA. DO by OB equal to CO by OA. So here we write the, here asking AO by BO, CO by DO. So we write the reciprocals here AO by BO. So here we write that form. That form means first here, so here DO carry to right hand side, AO carry to left hand side. So that implies OA by OB equal to CO by DO. So this is the required proof. Here ends proof. So this is the complete solution of 8th one. So here 9th one, draw a line segment of length 7.2 centimeters and divided it in the ratio 5:3. Measure the two parts and verify the results. So here we draw the line segment. That line segment ratio, total line segment length is 7.2 centimeters. 7.2 centimeters line segment, we divided the 5:3 ratio. We divided the 5:3 ratio. So here first we draw the line segment. So here we draw the line segment 7.2 centimeters. So here use the scale and draw the line segment on 7.2 centimeters. So here 7.2 centimeters, here A to B is 7.2 centimeters. So 7.2 centimeters, here ratio is the 5:3. 5:3 means here 5 plus 3 equal to 8. Here ratio is 5:3. 5:3, sum of the ratios equal to 8. So now here we use the scale and draw the acute angle at A. We take scale and draw the acute angle on downside. This is the acute angle. We write the ray X, AX. So now here we use the rounder. Here total 8 parts. So here sum of the ratios equal to 8. So this AX ray we divided 8 parts. We take any small distance on rounder, small radius, take on small radius on rounder. So don't change this one, just here first started with based on A, we draw the arc on AX. Next, here A2, this point is A2, A1. So here A1, based on A1 to draw the another arc. This is the A2. So next, based on A2, we draw the another arc, A3. Next, A4. Again, we draw the another arc, same radius. Here total we draw the 8 arcs. So here A3, A5, A6, A7, A8. So here we draw the 8. We draw the 8 arcs. Here now we join the A8 and B point. So here join these 2 points. This is the A8 to B. Now we draw the line, this line parallel line, A8, we draw the A8 parallel line. So here another point is here 5:3 ratio. So here 1, 2, 3, 4, 5, A5 here. So this point we draw the parallel line of A8 to B. So here we use the rounder. We use the rounder. First, we draw the one arc based on A8. Based on A8, we draw the one arc. Now, again, A5. Based on A5, we draw the another arc. So, same here now, we measure here to here how much. So, here same, here we take this radius, use here. So, here to here. Now, we draw the line here, this intersecting point to A5 to this intersecting point, we draw the line. This is the parallel line of A8 to B parallel line. So, C point. Now, here total 8 points. So, here total distance is 7.2. 7.2 means here 7.2 is divided 8 parts. 8 parts means here 0.89 is 72, 0.9. So each part 0.9. So here ratio is 5:9. So is 4.5. Next 7.2 by 8. Here 0.9 into another ratio is 3 equal to yes 2.7 centimeters. So now here we check it. So here we measure it. Here A to C distance how much? Here first use the scale and here 4.5. So here exact 4.5 is there. A to C. Here 4.5. Next here 4.5 centimeters. Next here we check it. C to B. 2.7 centimeters. 2.7 exact 2.7 centimeters. So this 7.2 line segment we divided the 5:3 ratio. 4.5 centimeters and 2.7 centimeters. So this is the diagram of the 9th one. So now we write the construction steps. So here construction steps: draw a line segment AB of length 7.2 centimeters and construct an acute angle BAX at A. So third point, mark of 5 plus 3 equal to 8 equal parts A1, A2, A8 on AX ray with the same radius. Next, join AI to B. Fifth one, draw a parallel line AI to B at A5 meeting at AB at C. So now the point C divided AB in the ratio 5:3. Measure AC and BC. AC equal 4.5 centimeters and BC equal to 2.7 centimeters. Next, eighth one, verification is, we are asked the verification. Verification equal to here, ratio is 5:3. Length of the line segment 7.2 centimeters. First part is the 7.2 by 8. So here 1's a 0.9's a 0.9 into 5, 4.5. Here also 1's a 0.9's a. Second part, 9 into 3 equal to 2.7 centimeters. So now this is the last problem of in this exercise 8.1, 9th problem. So complete of this exercise. Complete PDF link on description is there. If you are needed, download it.